Now I want to talk about reference angles. I sort of alluded to them in the last video, but I didn't really call them reference angles. So reference angles are what we use to try and find that smaller angle between our ray here and the x-axis. So you notice quadrant 1 is not on here, and that's because if it's in quadrant 1, it's the same thing. So if it's in quadrant 1, the angle is the reference angle, as long as it's positive and between 0 and 360 degrees. If it falls into another quadrant, you can kind of look at it and think about how you could either use subtraction or addition to find that angle. But it's going to be the same always of how you do it for quadrant 2, 3, and 4. So whenever it's in quadrant 2, so if you have an angle that falls here, you can always do 180 degrees minus the angle to figure out that angle in red, which is the reference angle. In radians, that would be pi minus theta. If it's in quadrant 3, see, now it's like you have too much, so you have to go back a little bit. So now you actually start with your angle and you subtract out the 180 degrees. Or you take your angle and you subtract pi. So that's going to give you that angle measurement in red, which is called the reference angle. And then finally, if it's in quadrant 4, you can take 360 degrees and subtract your angle, and that will give you the difference here, the angle in red, which is the reference angle. In radians, that would be 2 pi minus theta. Okay, so now for this, let's try and draw the angle, identify the reference angle, and then evaluate it. So let's first look at sine of 840 degrees. Let's focus on the 840 degrees first. So the first thing is that since it's larger than 360, I would use coterminals to get it to be less than 360. That would be the first step. So 840 minus 360. That's 480 degrees, still too big, so I would go ahead and subtract another 360, which is 120 degrees. Then we're going to draw it in the correct angle, or the correct quadrant here. So that's going to be in quadrant 2. So essentially what happened with our angle is that it went around once, and then it went around again, and then it did the 120 degrees. But it still lands in the same spot, so the right triangle that we create now is going to be the same as if it had just started off as 120 degrees. So now we need our reference angle in here. So this was 120 degrees, so we kind of need that difference in here. So we can do 180 minus 120. Which is 60. So our reference angle is 60 degrees. Now I'm going to draw that vertical line to the x-axis and fill in my values. Across from the 60 is square root of 3. Adjacent is 1, and then hypotenuse is 2. And before I try and answer what is sine of 840 degrees, I want to check my signs. Okay, so the 1 is in the negative direction, but the square root of 3 is in the positive direction. So the answer of what is sine of 840 degrees, sine is opposite over hypotenuse, so it's going to be square root of 3 over 2. Okay, now let's look at the next one. So I'm going to leave it in radians, just to try and show you how to work with it in radians. It says pi here, but I can just maybe rewrite this. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. So maybe you're looking at this and you're not sure if it's less than 2 pi or not. We can actually go ahead and get a common denominator even for these quadrant angles. So like maybe I'll start with 2 pi, and I could multiply that by 6 over 6 to get 12 pi over 6. So that tells me that my angle is not more than 12 pi. It's a little bit less than 12 pi, so it's a little bit less than a full rotation. So I think it's going to be in quadrant 4, but just to check, I can actually do the same thing with this 3 pi over 2 angle, is maybe you could instead multiply this by 3 over 3, and that's 9 pi over 12. So that kind of confirms, okay, I'm dealing with 11 pi over, 6. I'm dealing with the angle of 11 pi over 6, and that's in between 9 pi over 6 and 12 pi over 6. And when you are working with radians, I mean, for the most part, you can kind of ignore the pi that will be in all of them and just look at the angle. Look at the fraction measurements. So 9 over 6 and 12 over 6. So that means it rotates around, ends in that quadrant 4. And I want to find out my reference angle. So here again, I'll leave it in pi. So I want to take that full rotation, which is 12 pi over 6, and I'm going to subtract my angle, which is 11 pi over 6. So my reference angle is pi over 6. I will say when working with radians, pretty much all the time, you're actually going to be able to know the reference angle right away just by looking at the denominator. Because this was 11 pi over 6, my reference angle is going to be pi over 6. But you still need to do the work to figure out the quadrant so you get your signs correct, so that you know which quadrant to graph the angle in, and then which values are going to be positive and which are going to be negative. Let me draw my vertical line to create the right triangle here. So pi over 6 is the same as 30 degrees. So across from that angle is going to be the smallest side length, which is 1. So the adjacent becomes square root of 3, and the hypotenuse is 2. Now let me check the signs. So square root of 3 is moving positive in the x direction. 1 is moving negative in the y direction, so that's going to be negative 1. And now the last step is, once I have everything drawn out, I'm going to go back and look at my angle. Okay, sine of 11 pi over 6 is what? So sine is opposite over hypotenuse, so that's going to be negative 1 over 2. Okay, now let's do the same thing for our last one here. Negative 11 pi over 4. So if it's negative, you could convert it right away to positive if you want to. Maybe I'll go ahead and do that instead of trying to rewrite my quadrantal angles here. So let's go ahead and make that positive by adding a full rotation. So I could say negative 11 pi over 4 plus a full rotation is 2 pi. And if I multiply that by 4 over 4, I can rewrite that as 8 pi over 4. And if you add a full rotation, what you'll find is it's still going to be negative. It's going to be negative 3 pi over 4. So if you do want it to be positive, you'd want to add another rotation. So then you end up with positive 5 pi over 4. So tangent of negative 11 pi over 4 is the same as tangent of 5 pi over 4. So let's just work with that angle now. So I could get my quadrantal angles to have the same denominator. And I realize that my other one's kind of, let me erase this, it's kind of getting in my way here a little bit. So I want to figure out where this falls. Like I said, looking at this, the reference angle is actually going to be pi over 4, but we need to know where to draw it before we get to that point. So let's see, 5 pi over 4, well, if this is pi, That means that's the same thing as 4 pi over 4. So that tells me it's bigger, so it should be in quadrant 3, but maybe I want to go ahead and double check. Let me write 3 pi over 2. If I multiply by 2 over 2, that's 6 pi over 4. So that kind of confirms that my angle 5 pi over 4 is going to be in between 4 pi over 4 and 6 pi over 4. So that's where I want to draw the angle. We need to find the reference angle. I've already said that it's going to be pi over 4, but I want to show you the steps to do that anyways. So 5 pi over 4 is that rotation. So you would actually do 5 pi over 4 minus pi, which is 4 pi over 4, which is pi over 4. This is the same as 45 degrees, so that's the same right triangle that we're working with. So that means the legs of that right triangle are going to be 1 and 1, and the hypotenuse is square root of 2. Now let me just check all the signs. Okay, so this adjacent side 1 is moving in the negative direction for x values. The y value of 1 is also moving in the negative direction for the y value. So both of those are negative. Hypotenuse stays positive. So then to go and answer it, well, tangent is opposite over adjacent. So that's negative 1 over negative 1. So it's actually positive 1 for the answer. Here are a couple charts that kind of show when the different trig functions are positive versus negative. The one on the left, if you've heard anything like this before, which is all students take calculus, which we know is not true, but what it means is that they're all positive in quadrant 1. Sine is positive in quadrant 2, tangent is positive in quadrant 3, and then cosine is positive in quadrant 4. And you'll notice I said cosine, but if cosine is positive, then its reciprocal is positive too. So that's why you have 2 listed in either area. So you could remember that. All students take calculus to try and remember when it's going to be positive versus negative. You might also just want to look at it from what you know about the xy plane, so that if it's in quadrant 1, x is positive, y is positive, so they're all going to be positive. In quadrant 2, x is negative, so the trig functions that deal with x, which is the same thing as adjacent, that's going to be negative. So that's cosine and secant. And also tangent and cotangent have x values in them as well. X and y's are both negative in quadrant 3, and y here is equivalent to opposite. And that's actually why tangent and cotangent are still positive here, is because it's going to be opposite over adjacent, which is the same thing as y over x. So the negatives are going to cancel out. So that's why tangent and cotangent are positive here. And then for quadrant 4, you've got that x's are positive and y's are negative. Now let's look at this example. Let's say we're given that tangent of theta is equal to 2 over 3, and the angle theta is in between pi and 3 pi over 2. So I'm going to draw the triangle, but I want to make sure I draw it in the right place. So the fact that it's telling me the angle is in between pi and 3 pi over 2, that tells me that my angle is in quadrant 3. So it makes sense that tangent would be positive, because we just talked about how that's a quadrant where tangent is positive. So we don't actually know the angle, but we do have some information to actually draw the sides of the triangle. So if tangent of this angle is 2 over 3, that tells me opposite is 2 and adjacent is 3. Then I can go ahead and use the Pythagorean theorem to find the hypotenuse. Now I just need to use the definitions of the other trig functions and write down all the values. I'm going to start with tangent again, even though we already have it. And then cotangent, again, we could have found it without finding any of those extra values. We just have to write the reciprocal. Also positive. And actually, before I keep going, I just realized I haven't checked for the signs yet. So let me go ahead and do that. X's are negative, Y's are negative. So sine of this angle is going to be -2 over square root of 13. And I'm just going to leave it like that. I'm not going to rationalize it right now. Cosecant is going to be square root of 13 over -2. Cosine of theta is going to be -3 over square root of 13. And then finally, secant of that angle is going to be square root of 13 over -3.